Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Driving Engineering Forward with Innovative Workflows and Spatial Data. My name is Amanda Rogers and I will be your host today. Firstly, in keeping with our tradition, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with our industry partner, Neomap. Neomap is a market leader for cloud-based geospatial information services, ranked one of the 10 largest aerial survey companies in the world in annual data collection volume. Neomap's patented camera sensors and imagery processing pipelines are the most advanced globally, enabling them to capture and update the truth on the ground with industry-disrupting efficiency. With offices in the US and Australia, Neomap services a rapidly growing global base of over 10,000 customers, particularly government agencies and commercial enterprise, for whom current reliable ground truth data is essential to critical decision-making and operational workflows. I'd now like to welcome our first speaker for today, Steve Grigg. Steve has over 20 years' experience delivering transport projects across Australia and internationally. Steve has been working with transport authorities and state governments in preparing BIM strategies and digital engineering requirements for projects centering the approach around the single common source of truth, data. Steve currently works in Mott MacDonald's digital advisory team, delivering solutions for clients to help them realise the benefits that digital engineering can bring to their projects. Please welcome Steve Grigg.
Hi, my name's Steve Grigg. I am a technical director in the digital advisory team with Mott MacDonald, and very happy to be here today talking to you about driving engineering forward. So today's presentation, I'm really going to be focused around the I in BIM. So for everyone that I'm sure is aware of the term BIM, Building Information Modeling Management, the M can be different, but the I, the information, is key. I really want to talk about is how do we get the most from information? What are the downstream benefits, and how do we really kind of leverage that by setting ourselves up at the start, at the outset, at the inception, and how do we set that up to make sure we're getting the best from it as we move along in the project lifecycle. I'll share some of my experiences of what's happening, what I'm seeing in the industry now, what I'm talking to clients about, and also talk to you about some of the things that I think are going to be happening, and some of the trends that will be I think will be happening in the coming years. So just a quick intro to Mott MacDonald, just to give you an overview. Mott MacDonald are a global engineering, management and development consultancy. We work in over 135 countries with 18,000 staff, over 18,000 now, and have over 150 years of heritage. So we've been around for a while. For us, our purpose is to improving society. So as engineers, improving society by looking at the social outcomes and with a focus around excellence and digital innovation. And this really is why we're here. Me as an engineer, this is why I'm here, to try and make a difference, to try and focus on that excellence whilst transforming businesses and the societal issues. People's needs and their aspirations change, and they change fast. And what that does, it puts an increasing challenge on our clients who want to satisfy their stakeholders whilst trying to kind of tackle the societal issues. And at the centre for me is digital innovation. How can we embed digital into everything that we do to make things more efficient and to get the best result for us as engineers, for our clients, and for that society in general. So, like I said, I want to talk to you about information today and data. And central to a successful data-delivered project is, having the whole process connected. So, connected people, connected systems, and connected thinking. All these are really made possible through information. So, by having the right information with the right requirements set out from the start, will really lead to better outcomes. So how do we do that? It really starts with the right information strategy from the start. So looking at having the right standards, having the right protocols in place and the right processes, ensuring that we do have the right people with the right skills. And then once we have this, embedding this into the business, embedding this into your projects and making that call that this is the way that we're going to move forward. And it really does kind of support that overall holistic, decision making and decision to move forward in that way. The future of engineering, it will change. It is changing now. It's always changing. And what we're seeing is there's new processes, new workflows, new, more advanced software, and different skill sets are emerging in the engineering space. Ones that didn't exist 5 or 10 years ago, and no doubt in 5 or 10 years' time there will be new skills, new roles that are required in the engineering profession that don't exist now. So just to touch on BIM, and I spoke about it at the start. I suppose I'll caveat this with, there's lots of definitions for BIM, and many organisations have their own kind of angle on it. And whilst a lot of them are all slightly different, there's most of them kind of touch on the kind of the key themes. The one on the screen there is Mark McDonald's definition, which has been largely unchanged since 2010. But for me, really, the key themes that come out of a lot of these definitions is coordination, so a coordinated approach to what we're doing from a design perspective, from a construction perspective, overall project lifecycle coordinated. Information, which is the key thing, key theme for me today, and also life cycle. It's not just about any one stage of the project; it's about the entire project life cycle through, planning, design, construction, handover, the whole way through. So that's BIM, and like I say, that there are lots of different definitions, but that's the one that I'm going to go with for today. So key to information is the data, and the data that we generate during as we're kind of creating the information for our projects. And the diagram there is, it's a typical life cycle of a project. And whilst I acknowledge that, some projects, may not follow that specifically, there may be additional stages, or they may not have some of those stages. Generally, the preparation, the brief, the design, the construction, handover into asset management, eventually into demolition, decommissioning. The golden thread is a term that I believe it was originally coined in the UK, but it is a term that I've started kind of seeing kind of socialised in Australia. Clients have been talking about it, and other kind of peers have been kind of discussing it as well. And what it really relates to is having that kind of quality, up-to-date information throughout the life cycle of an asset. And whilst that might sound like a digital twin, there are differences. For me, a digital twin really is, it has that kind of current representation. That's what it's really about, the current representation of the asset right now, with that kind of live data feeds and that, the real-time information. Whereas the golden thread, whilst it is up-to-date information, it contains the entire record of the asset from cradle to grave. So, it still kind of contains that, the original information requirements. It contains the content around the project information model, so your 3D BIM model from the design and construction phases. It has all of that as constructed data that's been that's handed over during the handover phase, and then you start to kind of build in the asset management information. So by having all of that information in those assets, in those models, in that database, however it's being managed, it really kind of supports that kind of longer term use of the model, and really gives kind of value downstream. So particularly in the kind of construction, but more so in the asset management space, and really kind of helps clients to drive and get the most out of their information, and helps with stuff like more informed decision making. If that information is available, it really gives you everything that you need to better inform decisions. So that's why data is so important, and this kind of this idea of the golden thread is kind of more and more prevalent. So how do we actually how do we create this golden thread? How do we create this data, and how do we keep it all together? So in the BIM world, we have this kind of term called a CDE, a Common Data Environment. A CDE, many of you may have heard the term, and if not, the chances are you're probably working in some kind of CDE anyway. Common data environment is essentially a single source of truth for your project data. All the project stakeholders can access this information, and it contains all the data for the project. So depending on the type of project you've got, it may be drawings, it may be models, spec sheets, reports, spatial data, geometric data, anything related to the project sits in your common data environment. Now, the thing that makes a common data environment kind of stand out from a normal kind of just file management system is the fact that it has workflows in place, so approval workflows to make sure that the data that's being fed through and being shared with people has been approved for use. But additionally, it also has metadata on it, so that's where we're assigning extra information to the documents. It's not just a document name, but it actually tells you more about that document as well. Now, in an ideal world, we'd have this one system, a common data environment where everything's housed and everything sits on, and it's one system that we have to manage. But the reality is, and particular for me, I'm in the working in the infrastructure space, linear infrastructure space. We often have to deal with multiple common data environments. So really, then it's bigger than a single system. And what we tend to find is that some of the kind of advanced modeling platforms that we're kind of dealing with in the BIM space, they just don't they don't kind of function. They only function on their own systems, so they have their own bespoke systems, and we have to deal with that. We have to look at how we can actually manage that. So sometimes you may have these systems. We're going to call them WIP CDEs. WIP standing for work in progress. This is where your data is generated, your model content is generated, your design information is generated. And then once it gets to a point where we're ready to share, it moves into the kind of the primary common data environment, and that's where it enters that kind of that workflow where it's checked and approved, and we'll make sure that it's got all the right attributes and all the right information in there. But to do that, we need to have special integrations. It may be that there may be off-the-shelf integrations, but it may be that we need to use software engineers and data scientists to actually take that information, automate the transfer of information from one to another, to make sure that we have that latest information. So it starts to get a bit more complex, and you can start to see then that, yes, we have this common data environment, but there's lots of other skills required to actually manage and maintain that information. On the other side, once we've actually approved data for sharing, we then have stuff like how do we review our 3D models? How do we review our drawings? How do we consolidate the comments across those platforms? And how do we push it out to model federation tools to do things like clash detection? And then your other systems like analysis and geospatial data, so GIS data and stuff like that. So there's lots of interconnected systems, many of which need kind of custom integrations or just kind of people that are specialists in that space that understand how the back end of these softwares work. And a key thing to the common data environment, many of you may have seen this graphic, but it essentially demonstrates how information flows through a common data environment. So the blue box there, work in progress, is essentially that kind of WIP area where we're doing our design, and where it's only kind of contained within that current discipline. So be that highway designer or bridge designer or electrical engineer, they're working in their space now. And until it's gone through that approval workflow and been checked for, content accuracy, content relevance, making sure it's got all the right metadata attached to it, etc., it can't be seen by the rest of the team. And once it's been through that process and it's been approved, then it goes into the shared area and everyone else can see it. So that's the basic kind of concept of the ISO 19650 framework to approach to a CDE. And eventually, once it's been shared and everyone's coordinated and they're happy with the design, eventually it goes through an authorization process and is issued to the client. So that's the kind of the concept of the CDE and how that again that kind of golden thread of information kind of continues through that process as we go through the design process and into construction and onwards. So digital by default, I suppose I wanted to touch on this because I think it's a really important idea. And in a new world now of BIM modelers, BIM coordinators, BIM managers, information managers, computational designers, parametric designers, etc. We have lots of these new roles that are evolving and emerging that weren't there 10 years ago. But the way I see it is that eventually these roles will become part of the engineering team. where our kind of domain kind of leaders now, so our highway designers, our bridge designers, they're going to eventually build on these skills and have these skills themselves, and that becomes part of their role. We the current crop of leaders that we have now, eventually 10, 15, 20 years time will move on in their business roles, in their kind of positions, and the emerging leaders that are coming through now, they're digitally native. What do I mean by that? Digitally native means that they're coming in, and not only do they have an engineering background or an engineering qualification, but they can also code. They can also write programs. They can code in many languages often. They can write programs. They've got advanced modeling skills. They understand data analytics and how to get the most from it. And they understand automation and how they can use things like machine learning and stuff like that. So it's a very kind of different, more advanced skill set of people. And eventually, like I say, in 10, 15, 20 years' time, these people coming through uni now and kind of the education system now will be our future leaders. And it's going to be a very different landscape with the kind of skills that they have that they're bringing to the engineering workforce. So just kind of keeping on that, I suppose, emerging trends that we're seeing, things like machine learning and artificial intelligence, not the thing of science fiction anymore. Machine learning is being used today, and we're using it, today, removing the need for that kind of manual process, manual tasks, and being able to apply that to, take our kind of domain experts away from doing those manual tasks and let them focus on what they really want to be doing, which is, problem solving, engineering. Tools like computer vision, where we can use kind of image recognition software to kind of draw from previous data that the tool has seen and take actions or make recommendations based on it, is real and being used today. Artificial intelligence, whilst there are some pockets of it being used now, it's maybe not kind of hit its peak currently, I'd say, but definitely will. There's massive kind of opportunity for artificial intelligence in engineering and how we use it. And looking at other things like human-centered design and looking at design from a human perspective. Like I say, some of these roles didn't exist 5 years ago, and there's also a difference in the kind of qualifications that we look for in the engineering team. People that come out of uni with video game design, data science background, computer science, people that understand data analytics, maybe weren't traditionally looked for in the kind of engineering practice 5-10 years ago, which is now a really important part of the engineering team. So just want to kind of touch now on this concept of digital twins, and I know many of you will have will have heard the term digital twin, and many people again will have their own interpretation of what it is. But there was this paper that was authored recently by the Centre for Digital Built Britain, UK National Digital Twin Programme, and it really kind of calls out on digital transformation and how the smarter infrastructure really is a digital representation and a digital twin. So I thought it was a really kind of interesting concept that they talked about, and I wanted to touch on it briefly. So the paper was on flourishing systems, and like I say, it was authored by the Centre of Digital Built Britain. But they talk about the purpose of infrastructure is human flourishing. So what do they mean by that? I mean, human flourishing isn't a new concept by any means. It's actually a very old concept. Probably can be dated back to kind of ancient philosophers in Greece, and talking about that basic human need. Human security, human kind of happiness, and it kind of it can be kind of translated back to this kind of concept here, which is infrastructure being a system of systems. I suppose, what do we mean by that? We can see on screen there, you've got your kind of different levels of systems, and they're all interconnected and interrelated. But the key thing across all of this, again, coming back to the theme of this kind of talk, is information. If we don't have the right information schema at the start that kind of defines exactly what we're trying to achieve in the long run, there's no way that we can achieve this. So looking at the way we kind of link the kind of economic, the social infrastructure, into the natural environment, which links all of our kind of transport systems, power systems, healthcare, housing, all those interactions, all those connections, really does create that system of systems. But it's founded on an information schema and an information system. So it's kind of bigger picture, but it's it kind of comes back to how important that that kind of thread of information is right from the start. So just staying on the digital twin theme just for a minute, kind of wanted to kind of talk a bit more on this kind of this system infrastructure being a system of systems. And if we take this example of this pyramid here, and I'm going to use a linear infrastructure, a bridge analogy. And if we look at this and say that this pyramid is a digital twin of a bridge, and then we look at the second pyramid and say, well, this is a digital twin of the interchange. Now, the interchange contains the model, the digital twin of the bridge. It also contains models of the lighting, the ITS, the civil design, the earthworks, the retaining walls, the noise walls, the signage, the gantries, the underground utilities. It contains all of that, and that is a digital twin of our interchange. Now, if we move it one step along, the next pyramid is the digital twin of the highway. So the highway may be a 50-kilometre stretch of highway that has 10 different interchanges in it. Each interchange has all of those individual systems that we talked about at the start. And then I suppose taking it to the final level, this pyramid represents a digital twin of a state's road network. Again, multiple highways, each have multiple interchanges and each have multiple individual systems within those interchanges. And you start to see that by having that kind of information, being able to federate all that information through and connect those digital twins together through a common platform, we're able to have this kind of linked system of systems. And look, from an asset owner, it really enables that effective kind of interface management, ensuring that everyone's got alignment and that we're optimizing designs and our decision making for the same joint outcomes. So, just kind of moving on to some of the kind of the benefits of this kind of this golden thread, this kind of information through BIM and through using this kind of having this platform of information at the start to really kind of benefit us downstream. I want to talk about sustainability. So it's going to become increasingly difficult to sustain infrastructure and society unless the systems themselves become sustainable. Parts of the industry have already started to recognise that reducing carbon can help to reduce costs, as well as have that kind of positive impact on on the future and sustainability. And look, we have tools, and we're already using tools that can help us with this. So just an example of a tool that we use here, which is working towards that kind of net zero carbon future. We can use this tool, which is an online tool, to calculate how much carbon is in our designs. But in order to do this, data and information is key. We need to have the right information embedded into our models when we're developing them at the kind of inception. So the kind of calculation that Carbon's looking at here is how much concrete is in that design, how much reinforcements in there, how much steel, how much is the new road corridor deviating from an existing corridor? Is it a greenfield or brownfield? That kind of thing really allows us then to accurately measure the carbon footprint of our designs. And then we can have multiple designs compared, and it will give us an overview to kind of give us that kind of optimal design solution, not just based on cost, but looking at the that carbon footprint there as well. So a really useful way of using the information that we're embedding early on in that kind of downstream aspect. So the other thing that another thing I want to touch on is the use of visualization engineering. Now, many of you you see when these big projects come up, there'll be a visualization, a fly through of the project or whatever it might be. And the way we're using the visualization is we're actually using the data generated during the engineering design process. So these are not just pretty pictures; these are actual visualizations of the actual geometrically accurate models. And there's a number of uses, and these are just a few that are on screen here. But the first one there demonstrates how we can use information from simulation tools. So simulating people movement, pedestrian movement, peak flows, and that kind of thing, traffic movement. The second image just kind of shows a typical fly through visualization. So using 3D images, 3D animations, renders. But also more recently using kind of real-time engines, so where you can actually walk around and engage with the model. So you can actually walk around and see your asset, your building, your road, your bridge, your rail corridor, whatever it might be, before it's even started on site. And also there's the emerging use of kind of augmented and virtual reality. So the picture on the right there is a screenshot from a virtual reality, and this was rehearsing some site movements. So the placing, the delivery, the movement of materials on site, going through and looking at it from a health and safety and a risk management perspective. Months before we even start on site, to look at, well, can we actually make this practice safe? Is this a kind of safe way to do it? Or if not, kind of planning around that. So some kind of really useful, uses of the information models. And again, a lot of that is linked back to the information that we put in at the start. So yeah, I just want to touch on some of those things. So looking forward, and that future of engineering, I suppose there's some really good work and standards being developed now. Particularly at state government level, which is in the kind of linear infrastructure and transport space. There's a lot of great work being done in New South Wales, Victoria, Queensland, and other states. And we'll start to see that kind of regional approach and regional guidance come out from organisations like the Bim Advisory Board, Australian Bim Advisory Board, and obviously we have that ISO 19650 framework, which was originally based on the principles in the British standards from a while back. I often get asked about, the move away from drawings and reports and just going to a kind of digital delivery system, where information is the only kind of information, the only, project delivery. And what I could say is, after being in the industry over 20 years and being constantly told that drawings will be gone within 10 years, they're well and truly still here, and I think they'll be around for a while. But it's an interesting point. Whilst drawings and reports will still be there for a long time, information does become a standard delivery as well, and we're already seeing that. The request for BIM models, IFC information. So IFC's information industry foundation class. So that's a kind of industry-wide format that everyone can read their kind of model information. So whilst we're being asked for that, we need to start looking at, well, how do we support that? How do we maintain that? And what happens when that becomes standard? And new streams of digital engineering are starting to come online. Talked earlier about those kind of integrations to the kind of systems that we need, and that's in that software engineering and systems architecture space. How do we best position ourselves to make sure that all the different platforms talk to each other in an efficient way? And that's where that software engineering and software systems architecture comes. And then I suppose as we move into a space where artificial intelligence starts to become commonplace and machine learning really takes over, we have to ask a question. Who's asking questions of the AI and who's keeping this in check? And I think this is where additional kind of roles and skill sets like data resiliency, cybersecurity really come into their own and become part of that digital engineering team, and therefore part of the overall engineering team. So just as a kind of a closing thought, to support digital transformation, we hear about this all the time, but to support that, the teams need an intimate understanding of that kind of, the systems and processes and that kind of domain experience, not just of where we're trying to get to, but also of where we're currently at. That's the only way that we can transform. And, key to this is that kind of that digital integration and digital expertise. So domain experience is key, and having that engineering experience. But implementing digital and bringing that along for the journey, and really having that kind of that basis of information from the start is key to a successful transformation. I've been Stephen Grigg, and thanks for your listening today.
Thank you, Steve, for your insights. I'd now like to welcome our second speaker, Ben May. Ben is a digital evangelist with over 20 years of experience, both locally and internationally, leading the delivery of projects across the built environment sector. An early adopter of BIM within Australia, he has worked exclusively with Revit and building information modelling since 2006. Ben's BIM and digital experience includes implementing and managing digital workflows to combine process, technology, and people to maximise project outcomes. His current focus is on transforming AECOM's Australia and New Zealand buildings plus places business by embedding digital workflows to streamline and enhance project delivery. Please welcome Ben May.
Great, thanks for that intro, Amanda. Just a bit more about myself first. My background, as mentioned, is in structural engineering, and I've always had a keen focus on technology. I was a very early adopter of BIM, mostly through specific projects. Earliest on, I was working on the Royal Children's Hospital here in Melbourne, one of the early projects adopting BIM here back in 2005. I then spent a few years over in Europe working with Arup at a really exciting time in their organisation, mostly working out of their Dublin office. And this was when they were finalising the Beijing 2008 projects over there. So really some interesting things I learned and picked up over there. Back in Australia, I joined AECOM in 2011, and this was a real refocus for me on the multidiscipline approach to delivery of projects. In that time, we also added some capability around client-side BIM advisory, and really starting to see the interface of end-to-end implementation on projects. My current role in the last 2 years has moved to an Australia-New Zealand role in our buildings and places end market. This still includes BIM, but is often more focused on our business-wide innovation leading to transformational outcomes. Just a bit of a short summary on AECOM. Most would know of the presence in the market, one of the leading companies within the market, both locally and globally. And like many companies, AECOM has a renewed and focused vision on digital. Over the past 12 months, we really see us take advantage of this, particularly our scale in a global capacity. And things like BIM adoption, we're really able to leverage right across our organisation. So today, I really wanted to share some of the experience that I've had in BIM over the last 15 years. And given the audience, I was hoping to share some of that experience, particularly in relation to the Australian context within an engineering practitioner space. I'll break this into a few key areas that I see as important, which is people, process, and technology, and where I see BIM overlapping in this space. I'll cover some key insights and drivers within the market, some project trends that I'm seeing, some technology trends and how that impacts our delivery, and the changing roles within our teams. So firstly, let's start and review the term BIM and what it means. I really like this description by the EU BIM task group. And they say BIM is a digital form of construction and asset operations. It brings together technology, process improvements, and digital information to radically improve client and project outcomes and asset operations. Furthermore, they say BIM is a strategic enabler for improving decision-making for both buildings and public infrastructure assets across the whole life cycle. It applies to new build projects, and crucially, BIM supports renovation, refurbishment, maintenance of the built environment, and it's the largest share of this sector. This term's been very controversial more recently over recent years, and it's still important. And this is an important question to ask your project audience to ensure you're all talking the same language. There's many interpretations of the word BIM. The first paragraph for me here summarizes the broadness that the term covers, with the key point being technology and process. We often see people within our teams stuck on one or the other, and that's where their focus lies. You, of course, then add people to this, and the overarching project or enterprise framework for delivery is how it all comes together. To complicate the issue, BIM has been seen by some of the counterparts in infrastructure space, for example, in Australia, as a term that doesn't quite fit their sector. So now we have the emergence of terms like digital engineering or DE being more widely used in these spaces, which might fit their purposes a bit more. Essentially, these often go hand in hand. And for me, I see this DEs as the concepts and technology applying across both. Where I see the major difference in BIM is that we're trying to capture the full project under one term, the full project life cycle. While DE seems to be a little bit more focused on the design and construction areas of our delivery. We often then see the term information management added to digital engineering, complicating the discussion a little bit further again. So then we come to the client trends. To support all of these activities happening in BIM and digital engineering, we first look at the early days of BIM, and we look to the USA clients over there, like the Veteran Affairs, had standards and processes in place, and we looked at things like the American Institute of Architects, AIA, and they had the early standards and processes that we looked to adopt, which were very much technology and process driven. More recently, we see the globe shifting to the UK standards, and they're taking a more of whole of project, whole of government approach. And Australia and others are moving towards these standards as a way of delivery. With some early success, we're now seeing acceleration of these new standards by our clients, where specific definitions and requirements for BIM and digital engineering are emerging. These are often taking many different forms depending on the maturity of the client standards and the intended uses of BIM that they're looking for. At its most simple format, clients will most likely embed some high-level requirements within their tenders and their briefs. These might outline some specific deliverables and process requirements in regards to how those might be achieved. At the other end of the spectrum, more mature clients are having specific documentation around how they expect this to be delivered and how it fits into their own technology processes and their organizations. Through this, we see the emergence of documents like employers' information requirements and organization information requirements. It's important here also to note the procurement process can have an impact on how these projects are designed to be delivered. Particularly in my own sector in buildings and the built environment, we're typically still in a design bid build phase, project delivery model, where the contractor may not be known when we're setting up the project at project execution stages. This can have an impact later on, depending on how we've decided to deliver the project. If we look to a more specific application of the process, ISO 19650, coming more out of the UK once again, this framework is becoming the industry standard for definition of the approach requirements. Importantly, this is a not one-fits-all approach to all projects or assets. This goes both for clients who might request now information management to be ISO 19650 compliant, similarly to how in the past we might have had clients asking for BIM delivered to LOD 300. There's obviously part of the requirement here, but there's very detailed specifics in those workflows on how these outcomes might be achieved. The detail they are applied can vary significantly, and a single statement is not easily measured or assessed against. Some of the benefits that we're seeing with ISO 19650 approach is the alignment of the process to a common language across the project contractual framework. Some key questions, as I mentioned at the project formation stage, what's the maturity of the client? Do they have already defined information requirements or asset information requirements? And is the client likely to make benefit of these in the near future? If the answer is no in this case, there may still be avenues that the project team can take benefits as well. How are we designing the information workflows during the project delivery? Is there opportunities for the project team to benefit, with the client also benefiting from the outcomes? These are the key questions that we should be asking at project inception phase, helping embed these workflows to achieve project efficiencies. For further reading in this space, I would highly recommend Standards Australia, who have developed an ISO 19650 guide led by industry practitioners. This is a really useful reference point, and I'd really highly recommend people looking into this document, which helps guide them into how they can adopt it for their projects. So you might ask, we've been talking about BIM for years now. Why now will we see more rapid adoption by our clients? And as mentioned earlier, I've been in this space for over 15 years, and looking back from where we came from, we've certainly come a long way in that time. BIM benefits are now becoming more clearly understood with this more process-driven approach. The infrastructure boom that we've all been hearing about is accelerating this, and it is important from a client operational point of view, but there's also a factor of a fear of missing out as well at the same time, I believe. My view is the adoption is driving necessary innovation on delivery of projects, which is essential in supporting the scale of investment that we're now seeing, which is unprecedented in the infrastructure space. Secondly, I do believe clients are being more supported more than ever with the growth of experienced people within the industry and the knowledge sharing that's happening between organisations and authorities as they mature through this process. And we're moving to adapt and leverage the available outcomes that are being made available. And this collaboration between the authorities is really important to this adoption, where we're seeing each player building upon the last, which I think is a really great outcome through this process. So as I mentioned earlier, when we look at BIM and digital engineering, we're considering people, process, and technology. So I've spoken a little bit about the processes, and on the technology side, I wanted to look at a few key areas I see impacting engineering. Because technology is such a broad topic, I've broken these down into a few key trends across 4 main categories I see impacting our industry: CDEs or common data environments, analysis, data, and artificial intelligence and machine learning. Common data environments, or CDEs, are really the backbone of delivery. Important to note, these are typically quite focused on specific workflows within our delivery framework. In many cases, it will be a series of connected data and common data environments forming the project delivery. I've highlighted a few of those key platforms we see typically within the engineering process in the images above. CDEs form the backbone of the ISO 19650 delivery framework and enable the structured data workflows necessary for the consistent approach to BIM delivery. The importance here is documenting the processes and how the platforms are used for the project. In many cases, we're still seeing these underutilized in the functionality of how the platforms are used. And designing the project-specific delivery platform is really essential, particularly as we get into larger, more complex projects that have differing needs. Now, I just want to take some time to highlight some of the more emerging applications of BIM and digital engineering that we've been seeing in recent years. Like I said earlier, it's been expanding rapidly within the infrastructure space, bringing together a broader collection of specialists on large complex projects compared to what we may have seen in the past in a traditional building sector BIM application. Technology in this space has rapidly evolved with moves towards object-based modeling, and focus here has been on coordination processes to better leverage this approach. An example that we've seen here in Melbourne is on the Rail Infrastructure Alliance project in Melbourne. The project was an early adopter of a digital coordination meeting approach, which has been proven highly successful. The DCM, as we termed it for short, was a process of structured model-centric project collaboration, where the meetings enabled the project stakeholders, including the design managers, package design leads, the contractor, and other key project stakeholders to flag and resolve project design and construction issues while recording and tracing them via a digital cloud-based environment. Following the success of this process on the RIA project, it's now been established as a gold standard for delivery of rail projects Victoria. We're now further seeing this adopted right across Australia on many infrastructure projects, a real example of how digital engineering has been successful on infrastructure projects. And now moving to some analysis. Analysis is obviously a key component of how we deliver engineering. The vendors here promise design automation and seamless process. But of course, we must also ensure the analysis process aligns with the overall delivery. And designers need to understand the underlying principles of the analysis being undertaken. We can't just rely on the technology alone. A key benefit that we do see in the evolution of the analysis within BIM and digital is providing us with more information through the process to assist in the decision making. This is particularly important when we consider the opportunity it presents in optimizing the project outcomes, whether that is by cost, program, or sustainability goals, as a few key examples that we're seeing as beneficial. Another benefit of optimizing the process is also minimizing the risk in the data handover during the process. There's some key areas emerging, such as cloud, and that's also been driven by the COVID environment that we're now living in. And also the interoperability between platforms is another key thing that vendors have been passionately working about over the last few years. Just touching on another emerging application area, a unique opportunity within the BIM and digital approach is to merge those design processes to support the decision making. This can of course be applied to many aspects of the process, as many tasks are dependent on input from one another. At ACOM, we look to embrace those overlaps. A process we have developed in this space is a building optimization tool with a sustainability approach. We figured if we can combine facade, sustainability, mechanical design, and then overlay cost, we can look to analyse more design outcomes with better supporting evidence to inform the decision-making process. It's only once you combine these processes that some of the opportunities are realised. Typically, you may only assess these designs in isolation, looking at the facade or the mechanical process alone. By combining that with cost and then embodied carbon early in the process, we can really start to capture unrealised opportunities and have better conversations on our projects with our clients. So you can see a trend here. Data is something that everyone can't stop talking about. We generate more of it through our designs than ever before. But how do we leverage this data to take advantage within the process? How do we create a more structured, or as a minimum, a connected data workflow, leveraging the available data? There are so many required handover points throughout a project delivery lifecycle that we often default to traditional delivery approaches. Unfortunately, working in silos due to the tight budgets and timelines, that we can't necessarily always innovate or embrace new workflows. How can we be smarter about how we use this data in an achievable, iterative approach? The answer is we just need to start somewhere. I've listed a few key focus areas that I am seeing within this space: spatial data, benchmarking, and asset data. Benchmarking in particular is something that provides significant value to the decision-making process, but not easily extracted after the fact from unstructured data. So we do need to start to work with that data better to make it more easily available in the future. Similarly, spatial data is another key component that's becoming more readily available through services like Neomap and can assist in extending your understanding of the design requirements, including historical information. Just a quick example here is our Melbourne office headquarters in Collins Square. Here we have brought in the design models and overlaid in the 3D Neomap spatial dataset. With something like Neomap 3D, we can now commence a project with key reference information to assist the decision making early on in the design space, in the design process, looking at the constraints. Only then, with the data capture and connected data, can we start to think about artificial intelligence or machine learning approaches to our design. Through the data connections, we can enhance the process via algorithmic methods. As a more immediate introduction, we can of course look at rule-based methodologies, but to achieve machine learning outcomes, we need access to very large data sets of learning information to train the algorithms of what the good outcomes are. For me, this is the key requirement for processes to create true benefits. The key challenge in this space, of course, are people as well. There is an obvious angle to be afraid of the progress of AI, particularly in our space. We've seen the sci-fi movies where AI will take the jobs, automating what we do as engineers and designers. But as technical specialists in our field, we do need to be seeing automation as opportunities and not threats. They will become some part of our process in the future and how we work. And to exclude those from our focus altogether, some will be left behind. The other important thing in this space is the competitors coming into the field, not traditional built environment sector competitors, but think of the likes of Amazon and Google, who have the investment capacity, see opportunity, and are bringing fresh perspective to this sort of field. And then we have digital twin and smart cities, a topic on its own, so I won't attempt to go into great detail, but I did just want to reflect on the areas as important to BIM in this conversation. In some areas, we've seen clients jump to these outcomes as a key focus. And quite rightly, they do sit much closer to most clients' needs in regards to operating their facility or on the bigger scale, their whole portfolio. For me, this is best described as something that can work in tandem with BIM, but quite oftenly at the moment, we don't necessarily see them fully embedded. The utopian outcome, of course, is the golden thread of information, achieved right through from planning, design, construction, operation, and even decommissioning. But this requires significant planning to achieve across an end-to-end delivery process. At this stage, clients are assessing the benefits and intended use of digital twin or smart precincts in cities, and can leverage just a small portion of the information through the process. Within industry currently, we see a real focus on spatial digital twins, enabling some interesting use cases. However, the broader integration of BIM seems to be something not widely in the core focus at this stage. Emerging use cases include sustainability outcomes, where digital twins or smart cities can be a valuable tool with others in overall planning, and evidence-based decision-making, like I referenced before. At AIDCOM, we have recently joined the Smart Cities Council of Australia and New Zealand, who is a really key player in this space in adoption. They've just recently released a draft version of the Digital Twin Blueprint. I'd highly recommend people take a look at it. Their intention here is to influence action and investment in digital twins within the built and natural environment. And they're looking for feedback on this document currently, so highly recommend taking a look at that. So we've now covered process and technology. Let's talk a little bit about people. This is a critical component that's most often overlooked. We typically have a few key BIM people that can help set up the project. And as we said at the start, BIM has been around for quite a while. The issue that we most often see is that clients, team members, and other project stakeholders all bring that unique lens on what BIM is to them or the role in the process. Clients and also other stakeholders are now looking for more tangible outcomes to add value to their process. We have skills across many key components in our team, and it's important to structure the approach to work collaboratively to achieve project outcomes. It's also important to remember the industry standards in this space are evolving. So one project to the next may require adaptation to the approach, which is important to ensure projects review the approach and socialize it with the team accordingly. This is putting a real strain on projects to have enough people to really embrace the change required on delivery and support our teams. So some of the roles that we do see within the BIM delivery framework, I really like to break this down into three main tiers within the organizational approach. At the top, we have the BIM advisory, and this is at the strategic implementation level. Depending on the project and client requirements and the maturity, we don't always see this on every project. But it's highly important for clients who wish to look for a contractual BIM outcome on their project to embed a client-side role in this capacity to ensure the defined outcomes meet their business objectives first and foremost, and they're also measurable and have controlled metrics against them. We too often than not, see clients asking for something that they literally just can't measure against. BIM management is the delivery side project leadership approach. And this is responsible for designing and reviewing the project BIM processes that were hopefully set by the BIM advisory consultant. Then we move to BIM delivery. The BIM delivery team is responsible for following the BIM processes and auditing within their own teams. This is the field we see with the most expanding roles and can work as an enabler, bringing together specialists. And we're more often than not seeing people like computational designers and integrated design specialists. It's a key to highlight BIM often only is the enabler here. So we're only bringing together in some cases the technology and processes and combining people from specialist areas that may not be BIM specialists themselves, but are adding to the process. So as I've come to a conclusion here, I hope I've provided some valuable insight to BIM through my experience. Success here is to ensure we have focus on all aspects of technology, process, and people. And we never stop innovating. It's a pathway to true transformation of our sector. So once again, thanks for having me and look forward to some questions.
Thank you, Ben, for your insights. I'd now like to welcome our third and final speaker, Fletcher Haywood. With 7 years of experience across government, engineering, and environmental management, Fletcher brings an extensive geospatial background to Neomap. Fletcher has a passion for aerial imagery and is now diving in with our AI product. He regularly leans on knowledge from his studies at Macquarie University and spreads it far and wide across the business with passion and eagerness for the entire suite of Neomap products. Please welcome Fletcher Haywood.
Thanks, Amanda. Neomap has been creating AI datasets, including building footprints, for the last 4 years. And with our newer generations, we have been able to add the peak height as an attribute to these building footprints. That means that this data could be extruded to the height and give a reasonably accurate but simple boxy representation of the buildings. This is a super fast and simple method to get some LOD1 data for your models. If you are looking for a little more detail, you can combine the building footprint data with the Neomap 3D. specifically the DSM and DTM. The digital surface model, as seen here, has a pixel size of 15 centimeters. This level of detail allows you to understand the slope of the roofs. What you see here is the pitch of the roofs detected using the Neomap DSM data. Using this data, we can separate the roof into segments, extract the roof form, and then finally fuse those roof parts. The output of this process, although I've simplified that process a little, results in an LOD2 building model ready for you to use in a range of different BIM models. Thanks.
Thank you, Fletcher, for that and bringing things to a close. That was a great session and we've had a great audience watching this afternoon. It's now your turn to get involved and our speakers will now come together to take questions from you. If you'd like to submit a question, the way to do that is to put it via the chat box on the screen. And please ensure you provide your name, if possible, and who you'd like to direct the question to. It is also nice to know where you're actually watching from, i.e. which state or even which country. Thank you also to everyone who sent through questions at the time of registration. So we might begin with one of those. We had a question that came in and it's for you, Ben, and it's from Ruben, and Ruben is in Queensland. Good afternoon, Ruben. And Ruben is asking, what are the biggest challenges to implementing these systems at scale?
Yeah, thanks, Amanda and Ruben. It's definitely a good question. I think really the adoption at scale is challenging. Really, as I sort of mentioned in my session, was about those sort of broad scope of benefits that we see and that we can achieve. And we're sort of really looking still a lot at the moment at the benefits to our individual outcomes. And I think as our clients are becoming a bit more mature and creating their own organizational approach to these outcomes, that we can really start to measure and I guess start to get better whole project outcomes. And that really just sort of builds into the investment and the progress that we can all get as an industry and as a group. So I really see that as one of the biggest challenges that we've seen for quite a while, but particularly as our clients really harness these parts of how we deliver our projects. That's really, I think, the challenge that we are starting to overcome now.
Thanks for that, Ben. Over to the west, Aaron in WA has put forward a great question about overlapping platforms. And Aaron's question is directed to you, Steve, that there's so much overlap in platforms. How can we make them cross-comparable? Steve.
Yeah, thanks, Amanda. Look, it's a good question. It's also a difficult one. I'm not sure if we'll ever truly have this kind of cross kind of comparable platform. But what we do have is things like open file formats, like the Ifc Format Industry Foundation class. And what it allows us to do is to for most of the common BIM software to read in that file. Not just the geometry, but also the actual data behind it as well. Look, there's good linkages between things like BIM data and GIS data, and some of the stuff out of the box. The software platforms now talk to each other, so there's good kind of linkages there. And look, from a CDE, from a platform perspective, in that sense, it is a common challenge. But I think there's kind of custom tools now. There's integrations that we can have to make sure that those platforms are kind of talking to each other, are able to share information between each other, and that we don't get that kind of loss of data between one platform and another. I hope that answers the question.
Thanks for that. Fletcher, do you want to comment on that at all?
I don't really have too much to add there. I think that it's a very complicated thing, and Steve has answered the question quite well.
Thanks for that. Back to you, Ben. We've got a question. You talked at length about BIM, and we do hear a lot about BIM and the misunderstanding around it. And I love that slide that you put up that actually gave that explanation. Scott in Victoria is asking a question. How does your BIM technology advance the needs for environmental assessment, control and works? And he's referencing tunnel projects, for example. Thanks, Scott. Ben.
Yeah, thanks for that question. Have to read a little bit into it because I'm not sure on a couple of the terms there around control and works, but I think it's more around, I guess BIM's generally used around that design and construction, and we don't tend to use some of the other, less design-focused areas like environmental. It's obviously a design, but not that sort of engineering core design of the actual asset itself. So I think it's really bringing together those other construction processes into the data stream. And as I said, BIM's really a digital form of that construction information. So as we capture more data through that process, we can look to leverage more of those data points. And I think environmental assessment is an area that is really gaining traction. And, it's really through spatial solutions that are becoming more commonplace. And BIM and GIS, you see the industry talking a lot about that convergence of those two technologies particularly. So I think those two, and that's something that at ACOM we've had a really key focus on. We do have some real focus around environmental engagement, and our focus there is bringing together both those data sets into a common platform, and particularly for the non-technical stakeholders to engage into that information through the process. So I think it's really connecting those data sets and making them valuable to the project stakeholders is the key. And obviously that can have a lot of benefits to the environmental, but then also the safety safety impacts and risk to the project as well.
Thank you. Does anyone else have a view? Want to jump in here? All good? We've had a question come in from Prathapa asking, directed to you, Steve, asking what level of detail, LOD level, are you recommending for Pavement digital twin in order to be useful during its service life? Thank you.
Thanks. Great question. I'm not sure if LOD is probably the right measure for the level of detail for a digital twin. More so that the kind of questions you need to ask is, what do you actually want to get from the model and the data? How are you planning on using that information further down in the kind of the life cycle of that pavement asset, and what kind of asset management system have you already got in place? What is that measuring? What does it have the ability to measure and to track? So, for instance, from a modelling point of view, do you just need to model the overall pavement box, i.e., a constant 500 mil or whatever it might be deep box, or do you actually need to see the individual pavement layers? I suppose the other thing to mention on LOD is that there's not really a single definition of LOD. There's lots of different ones, and whilst there are some that are a bit more common than others, LOD for linear infrastructure is still, I'd say, kind of being developed and means different things to different clients. And I think we certainly see that in Australia between the states at the minute. There's differences between what they're looking for. And it really comes down to what they're how they're measuring it and how they're using that information downstream. I think the other thing to consider is, what's your role on the project? Are you a designer? Are you a construction contractor? Are you an asset owner? Because again, I think the information that you're using is different at each stage. So doesn't quite answer your question, sorry, but I think there's probably a lot of things to kind of look at from that question.
Thanks very much. Thank you. And staying with you for the moment, Steve, we've had a question come in from Angeli, who is asking, how do you see the level of digital transformation at organisation level within government clients? Do they have systems and platforms for receiving digitally executed projects? Steve.
Yeah, great question. Look, I mean, being in the kind of linear infrastructure transport space, do a lot of work with state government clients. I think there's been a lot happening. There's been work happening there for a number of years now, and it's particularly been picking up in the last few years. Look, there's some great work coming out of in New South Wales with their DE framework. There's the digital asset strategy now in Victoria. And Queensland have their Bim for TMR set of standards. So there's a lot of standards there, and they're based on the systems that they currently have in place, where they can receive varying levels of information and data. I think one thing that's really helped over the last few years is the introduction of that international ISO framework, the ISO 19650. Because that's really given government departments a kind of a common framework to work towards with how they kind of build their standards. Look, I'd say there's still work to be done, and states are probably at varying levels in their kind of maturity and their transformation. But yeah, there's definitely some great work happening, it would be really good to see how that kind of rolls out over the next few years as well.
Thanks. Thank you for that, Steve. And Ben, over to you. We've had a question come in from Bill. Good afternoon, Bill. Bill is asking, with current advances in BIM, AIs and other technologies, how is the industry looking on blockchain technology implementation within the BIM environment? Thank you, Ben.
Yeah, sure. I'll focus on the blockchain, which I think the question is referencing. I spoke a bit about AI, but more around the design side of things. And I think looking towards the future, with successful adoption of BIM, blockchain within a smart contracts process obviously makes a huge amount of sense. And, it doesn't seem like a step too far, but then when you look at, the contractual requirements, that people would need to sign up to move to that, it does seem a long way away for me. We're still, most projects, the contractual requirements about the information we're delivering are still very much relying on the traditional delivery as well as the new delivery methods. So I think we've got a while to go there, but you see some of the issues that we have within our industry, particularly in the residential markets. I think governments are looking at these things. And there has been a lot of different initiatives with various legal representatives looking at the contracts, but I think it's going to take some success stories to move in this direction. And I think we've got the pieces coming together, and I think it's something that we can aspire towards. But it's going to take some early adopters to really drive this and prove that it can work. But I can't really tell you when that might be, and I'm not really sure anyone globally is really sort of using blockchain in that way. I think it seems to be a bit more academic at this time, but I think we'll see it in the not too distant future, I hope. I think it's a really great sort of thing that can be applied to our industry and the built environment.
Thanks very much. Thank you for that. Back in WA, Ian has put through a question directed to you, Steve, and Ian's asking, is BIM being targeted correctly, or is it still just perceived as a gimmick in general industry, i.e. to specialise? Common question, Ian.
Yeah, absolutely.
Steve.
It's a very common question, and a question that I, probably talk quite a lot about. I think for me, and what I've seen is that it really depends on how much emphasis has been put on it at the contract development stage and what you see in the actual contract documentation. If it's not a deliverable, then it probably won't be taken seriously by the project team. There's still very much, not very much. There can often be a reluctance to deliver extra things if it's not a contract requirement. So I think that's really key. But what I'm seeing more, especially in that kind of linear infrastructure transport space, is that it's almost a kind of business as usual now in contracts that we see. That there's a kind of a BIM deliverable. And I think you only have to look at the kind of the job ads out there for BIM managers, BIM coordinators, BIM modelers, people that have 10, 15 years experience in particular softwares that they can develop models and develop detailed models that's not just geometrically accurate but also has all of this data behind it. I think you'll see that that's just across both kind of engineering consultants and contractors. I think that there is really a push for industry to kind of they're upskilling and they are taking it seriously. And look, I think that's because the end asset owners are starting to see the benefits a bit more. It has been around for a long time. It's been something that has been talked about for a long time. But I think more and more was people are seeing the benefits of it, and it has been taken more seriously, which is why we're seeing it more as a kind of contractual requirement.
Thanks very much for that. And just staying with you, Steve, we've had a question that sort of touches on lifetime of buildings, and this is something there's many webinars in themselves that we talk about. But the angle Bruce is coming in asking you, design and construction takes maybe 1 to 5 years, but building life is 25 to 50 plus years of ongoing maintenance and alterations. How is old data kept live over many lifetimes of the supporting software? Great question.
Yeah, that's a really good question. I think the simple answer is we don't know. I mean, we've only been in this space of BIM for 10, 15 years. But what I can say is that, information that I worked on 20 years ago, albeit it was 2D CAD, AutoCAD drawings, MicroStation files, that kind of thing, can be open now. We can open them now and see exactly what was drawn 20 years ago, and probably even longer. So we have that information, but obviously the BIM data and the other information models that we're creating now are much more data rich and data heavy. I suppose one thing we do have is that Ifc format, which I mentioned before, and at the minute we're working on I think generally I'm working on 2.3. There's new versions out all the time, but I think that will be the format that we can use going forward, that we'll be able to link into either its asset management systems or load it into whichever BIM software we're using in 15, 20 years time, and we'll be able to at least open that. And even if we could just see the data and the geometry there now, that's really what we're looking for. So look, I think it'll be interesting how things evolve, because the models will get more and more complex. We'll be putting more and more information into them. But I'm pretty sure we will at least be able to open them and look at the data. And hopefully, I mean, the intention of BIM is that the data that we generate is not just for the kind of design and construction phase, but it's for the asset management and also into that decommissioning and demolition phase. So hopefully the data will be around and will be accessible in 25 or even 50 years time.
That's good to hear. Thank you. I've got a couple of questions here for Fletcher that I might group together, if that's okay with you, Fletcher. The first one is from Sina, who's asking, are the recent updates of Neomap for all locations? That's the first part. And then Bruce has gone on with a question, does Neomap provide any information regarding underwater sand levels, coastal erosion, sand movements, tides in and out to make this a challenging area to survey? Thank you, both of you. Fletcher.
Yeah, so I think there's a lot of different things to answer there. It may have been only 2 questions, but there was quite a lot. But I think I'll start with the first part from Sina, saying Neomap has developed that AI process, and we can do that process across any of the dates that we've captured, as well as any of the areas that we've captured. To add that 3D data, we need to use our special 3D camera, which we call HyperCamera 2, and that we can use on any area that we have surveyed in 3D. So we have a lot of areas, but it doesn't cover the entire capture region that we've previously covered. As for the underwater surveys, Neomap captures from an aeroplane, so the way that we need to capture, we need to be able to see it. And water is one thing that we can't see through on a regular basis, so we can't do those surveys underwater. But what we can do is supply 3D data and that AI data across all of the areas that we can see. So we know the times of capture, and you can look at the time of day on the date of those waterways that you are looking at, and from there you can get a pretty good understanding of the change over time. UNSW has done a really good study using Neomap imagery, and they've looked at the ways that waterways have changed and how that coastal erosion has been occurring over the time.
Thank you for that, Fletcher. Sort of coming back to sort of a bit of a theme of today as well is that Sultana has asked a question, pretty succinct, but I think he makes a good point. To you, Ben, he's saying BIM versus GIS or BIM and GIS. Why are we still in doubt?
Bad timing. The doorbell's just ringing. Yeah, no, I don't think there is. I don't think there is a competition now. I think it is it is something that does work in parallel, and I think GIS is certainly becoming the focus because of this talk around digital twins, and particularly the spatial part of that coming together. And GIS is obviously the best platform to bring that spatial information in, and I think we're seeing that only grow. And as I talked about, things like the environmental assessment side of things and bringing together those other data sources, GIS is really the right platform to bring in those data sets and help visualize. BIM and digital engineering are really focused on a smaller part of some of the projects. So I do see them working together, and I think the industry has sort of been on that path for quite a while already. So I think it's just a matter of time until that filters through to more and more projects.
Thank you for that. And it just shows we are live with that happening. So staying with you, Ben, but this question has also been directed to Steve as well. So I'll let you work out who wants to pick it up. And it's from Kesavan, and he's asking to us, do you see any issue in BIM implementation between the designer and contractors? How well equipped are the contractors in terms of these technologies? Who wants to kick off? Ben?
Yeah, sure. Yeah, there was actually a couple of questions I noticed there that had a similar kind of overlap, and I think particularly in the contractors space, there is a big variance in the maturity within their organisations, and I think that is accelerating. If you look on any of the job websites around digital engineering and BIM, that's the people who have been hiring in the last 3 to 5 years, and there is certainly a skill shortage of the people that are traditionally coming from engineering with the skill sets to go into those organisations. But those organisations, the big managing contractors, they're delivering a lot of complex projects. So there's still certainly a shortage out there, but I think that's definitely reducing as more people gain more experience, and I think they are doing a great job to meet those requirements. And I think then you get to the trades, and that does vary a lot as well. Some of the trades are working in quite traditional workflows still, and then we see in the services area they're really doing quite well from what I've seen. So it's a very complex area, and I think it's a challenging one. And as I said, the procurement process is also a big issue, and contractors are coming into projects that are well set up or not well set up in some cases. And that's sometimes an easy avenue to point fingers and say, well, we can't achieve these requirements that you might have, Mr. Client, because the design team hasn't done this or that, which may just be how they are looking to deliver. So again, coming back to the clients having clearer processes that they see as how their project should be delivered, that's helping solve this situation when we get to a novation or a construction stage with contractors. But there's some really great examples out there of some of the contractors that we have worked with, and a lot of them are really embracing technology and are really doing great things, I think. But I'd be keen to hear what Steve and Fletcher have to say as well.
Maybe we'll start with you, Steve. Contractors are adopting the technology.
Yeah, I mean, look, kind of echoes what Ben's just been saying about there. There's some really impressive work going on in the kind of contracting space, and there has been a big push in that industry to recruit. And they're really taking the information that we're creating, the design phase now, and adding to it. Adding stuff like 4D and 5D information to these models, to be able to simulate the construction sequence of how a project goes together. It's really impressive, and they can only be done with the kind of the skills and experience of knowing how to build those the assets, wherever it is. So look, some really kind of impressive stuff happening, and it's exciting to see where that's going to go. I suppose just on the first part of the question was around the that implementation between a designer and contractor. I think again I've had some really good experiences in the last few years with working closely with contractors, sharing information, and us both kind of really leveraging the information together. Where I said there's a bit of work to still be done is on some of those kind of commercial arrangements and the way things are set up. And it comes down to the way we share information, share data between each other. There's key times when you share the information at milestones, but in between that, it would often be useful to be able to share the information with the contractor, with the stakeholders. But from a commercial point of view, the way the contracts are currently set up, we're only sharing at certain times. So I think there's a bit of work to do sometimes with the way those commercial arrangements are set up. But overall, I think almost every project I work on now, there's almost a small evolution, like a small step change, and lots of those small step changes end up meaning quite a big change overall. So it's a good time to kind of be in this space, there is some really exciting work happening.
Thank you for that. Fletcher, do you have a view on that, or from a Neomap perspective?
Yeah, I think that one thing that Neomap sits within is that we are constantly on the cutting edge of technology. We're trying to push further and further into that realm of the unknown, where we can get data that then can be used. And sometimes we find things that is really revolutionary that it hasn't really hit the market yet. So we're the first to market. And with our 3D, that's one of those things that is 3D has been around forever, but the way that we've been developing it and pushing it is relatively unknown. And that's why we're working with these groups of companies to understand how we can better work within the industry and fit into these BIM and GIS models.
Thank you for that. We've got a couple of questions here that I might group together. We have a question here from Steve from Sergi, asking what is the current level of BIM implementation versus the traditional project delivery? And also Alan in Victoria, who actually directed this debate. So I might keep those separate. So Steve, do you want to just answer that question? What is the current level of BIM versus traditional project delivery? Do we know?
I don't have a figure for you, unfortunately. But again, from what I'm seeing, and I'm talking about from a major projects perspective here in linear infrastructure, roads and rail. Most projects that I've come across over the last few years now have all had a BIM requirement of some sort. Even tender designs, stuff that we're tendering on, like a reference design level. There's a BIM requirement. There's a requirement for BIM model data, a federated model. With kind of BIM formats, so Ifc formats and Navisworks formats and all that kind of stuff, and that's at tender phase, and then it just escalates from there into the detailed design. So for me, in the industry that I'm in, it's almost I'm not going to say 100%, but it's fairly up there with BIM implementation on major projects. Versus just a traditional, and I'm assuming from a traditional project delivery, he's meaning just 2D drawings and PDFs.
Yeah. Thank you for that. And we've just time for a couple more questions. So over to Ben. This is from Alan in Victoria asking, when do you think BIM technology will totally replace the old technique, AutoCAD?
Yeah, that's a really good question. Yeah, really good question. I think in some places, we're getting close. I think we are over the tipping point, and particularly in the infrastructure space. And we've kind of talked to that in a few of these other questions as well. Of the there was some other questions there around the the handover formats to the authorities and to the end clients. And I think that is something that's held it back. That the last 3 to 4 years we've seen clients with multiple, they're asking for almost 2 deliverables. They want the new deliverables, but then they also want their old deliverables as well. So I think that's a challenge. We spoke to some of the challenges in the construction space. Some of the trades are going to need the older deliverable formats for a little bit longer. We're quite progressive in Australia. If I go to conferences overseas, they're probably a little bit further behind just due to the scale of their industry, and there's more of those people that are maybe a little bit left behind and delivering how they have delivered. So I think we're looking quite good here in Australia. But we're going to see it for a little bit longer. We're going to see the need to, support some of those laggards, I guess, in the process. But I think the majority of what we're doing, we're finding those benefits, and the clients are seeing that now as well. So I think we're over that tipping point, and we're only going to accelerate further.
Thank you for that. I just want to finish quickly, and if we can just quickly. Today we have talked about innovative workflows and spatial data and driving engineering forward through this. For our young engineers that are coming up through the ranks or already studying, starting with you, Ben, and finishing with you, Fletcher, just quickly, what sort of advice would you have for our young engineers wanting to enter this field?
Yeah, I think just embracing the opportunities and and being patient though as well. Especially early in your career, you might need to push to get into certain spaces. You still need to go through those processes, but embrace the opportunities that you have and look to innovate where you can and hopefully contribute to that overall transformation.
Steve.
Yeah, look, I suppose it's similar to Ben, but I'd say learn from who you can, even though they may not be digitally native. They may not kind of talk the same kind of digital language as you. They have a lot of experience, so learn from them, and just think about how you can apply the extra skills that you have that that you're bringing, and how you can apply that to the to the field of engineering. And just embrace any opportunity that you can get, even if it doesn't seem like it's going to take you on the kind of right trajectory that you want. Those experiences, those learnings, they're really the same now as what they were 10 years ago, even though the kind of teachings may be slightly different.
Thank you. And Fletcher, do you want to just bring us home?
Yeah. So I think the biggest one for me has always been, actually, there's two things. One is have a mentor that can work through problems that you're having in your career, open you up to other opportunities. And the second one is also make sure that you're open to new technology, because new technology, like BIM, for instance, BIM is a new technology that is rapidly growing and one that is now a staple within the industry. And if people didn't bring that up or start working with it, then that would have been a lag in the industry. So I think, make sure you have a mentor, and Engineers Australia have a great mentor program that you could work with, and then also make sure you're open to new technologies.
Thank you for that. And, that's all we have time for. The questions are still coming in, so thank you for that. We'll look to a way to get back to you to answer those questions. But it is all we have time for today, and I know you'll join me once again in thanking Stephen Grigg, Ben May and Fletcher Haywood for their time, giving up their valuable time and sharing insights at today's session. Just to let you know, we've got more sessions coming up in this space, and we're also working with Neomap on their Navigate program conference, which will be held in November this year, attracting around 7,000 delegates. So an exciting space to be part of. As always, we'd appreciate your feedback on today's webinar. Helps us improve, helps us plan future sessions. So if you could please complete the short feedback form in the chat box, description box below. Thank you again on behalf of Engineers Australia. Thank you to Neomap for being our industry partner, and we look forward to seeing you again at our next webinar. Thank you and good afternoon.